Great. So thank you very much for staying here with us. Like Dejan said, my subject of this day, it's regarding with generative design for constructability improvement with lean and BIM approach. So let's see. We will start thinking about what are the needs that the society need to reach. And for that, the European Commission, it's trying to help all this change that it's happened because all the carbon emission that we have. The climate change is one of the main aspects that we need to cover in this couple of years. So one of the main issues is that now we need to reduce the 90% of the carbon emission by 2050. For that, we need to develop and we need to build differently if we want to reach that goal. And the good thing is we can have a lot of gap to improve because we are an industry that is fragmented and is lagging in technology adoption. You can see in the images that we are almost in the last sector that it didn't adapt the technology in the resources in the task. And for that, we saw the other graph where we can see that even we are less productive than that before, that years of the 70 and 60. It's mean that if we compare with other industry, our salary is even lower because we are not giving the profit the companies need to offer better salaries. And we have a technical and not technical issues related with the problem of the construction. One of the main issues is caused by a failure in exchange information and the lack of the consideration in the project constructability. This dissertation tried to identify the value and the integration of the mechanism for the improvement of constructability issues. We try to provide a comprehensive overview and analysis of non-technical and technical constructability issues. The case study is focused in the rationalization of the design. We are employing a generative design and machine learning approach to enable and informing the shaping of clustering of the building envelope. You can see in the image, we have one of the results that we create using this principle of constructability applying the technology. For that, I think it's well to understand what are these words, what is the power and what is the meaning of them. So in a brief, constructability technique examines the logic of the construction from the beginning to the end using knowledge management. We try to identify the obstacle, the restriction, and the potential problem to solve it before this happens. For other side, we have a Lean, that is a production philosophy for continuous improvement, supported by 4 pillars. By itself, the philosophy that it's a long-term thinking that help a lot to understand that the people is the most important part when we are develop a project. So for that, we have 1 pillar for people and partners that we need to respect, challenge, and grow with them. For the process, we need to understand what are the wastes that we have, like an industry. If we identify this wasted, we can mitigate them because we can create a risk assessment to try to reduce them. And finally, because it's a continuous improvement and learning philosophy, we try to resolve the problems, adapting all these issues that we will have with all this approach, philosophy, process, people, and thinking. And finally, we have the BIM, that is the interdisciplinary collaborative methodology that combines tools, process, and digital technologies. This is allows us to generate information and documentation on the project through its life cycle. So we can understand BIM like a management requirement, because now with the series of ISO 906050, we have this information management requirement that is for the construction industry. Additionally, it's a technological enabler that help to adapt the technology that we can use and we can improve, like a laser scanning, data analytics, 3D model, and so on and so forth. And finally, we are delivering a product. The deliverables are the construction document, and now it's the BIM model. It's the building information model. In the overview of non-technical problem, we refer for those that doesn't require a special knowledge of skill and it's still difficult to handle, causing delays or failure on this activity. Grifton and Sitwell, in his book, they define the non-technical factors like bad management system, personalities, and other. So we try to correlate these existing issues that we have with the mechanism that BIM and Lean provided. So one example is the light involvement. And for that, we have the integrate project delivery and the BIM approach, that if we remember the McLemie curve, we can see that the workload is in the planning state. So we can reduce the cost in the stages that it will be more expensive, that there is a construction. We cannot spend one day in the construction work with delays, because it's mean that we need to pay the worker, we need to pay the machinery and other stuff. But if we spend one day in the project, it's cheaper to pay the designers and the equipment that they need. And additionally, it's improved the way of collaboration, because it's a different mindset. It's related with how we can benefit all the stakeholders for this project, and we have reward for that. Then we have the communication files, and for that we have the common data environment and the BIM execution plan. Those elements allow to understand what are the goals, what are the requirements, and establish a place where we can work together. We have the lack of knowledge of capabilities, the bad relationship with the provider, and the lack of awareness of the project activities. And those are contained by the Lean philosophy, remaining that the people is the most important part in the process, and we need to understand what are the needs, what are the capabilities, and we need to grow with them. And it's better to understand in what stage we are doing this process. For that, the last planner system, using the master plan, the look ahead, and the weekly advance, we can give the information of the worker so they can understand better what is the status of the project. Then we focus in the technical problem of the design of rationalization. And this is because it's one of the most important issues that we have. One example of bad rationalization is the Opera House, that it was not easy to construct and had an inappropriate notion on structural honesty. For that, the overall cost was 1,400%. If we try to reduce the meaning that a good rationalization has, it needs to have a good modularization, repetition, and simplification. For that, we have several software that we can use. The procedural model started in the early 60s. Then we developed an approach of how to use these elements with the computational design, going to parametric design, and then the generative design. We have the platform that allow to help with the design rationalization. And then we have the specific mechanisms that we use for this case study. We define three phases. We define the pre-generative design, the generative design, and the post-generative design. In the first, we have this specific part where we set the goals, we reduce the variables to give the machine a problem that can be solved with the computation. And finally, we need to analyze them. For the case study, we have the STOSI Arena Hall, and we need to solve, or we need to help us solving some principle that constructability applies. And for that, we use the technology and we use the BIM and Lean mechanism. So in the dissertation, you can see in more detail what are the principles. So because I am with no much time, I will show you with a brief video what was the process that we used to develop that case study. So we start creating a parametric design with the shape. The main intention was not to create the same shape of the STOSI hull, sino keep some variable that help to try to find the optimal shape, so we can reduce the amount of material that we can use. For that, we use tools for generative design and use this tool with data analytics to get this Pareto optimal solutions, because it's important to check the information. We interoperate with SIA, that is a structural engineer software. We were doing the pseudo-structural analysis in Caramba using Grasshopper, but we need to verify that these results were okay. And for that, we compare both results and displacements and stresses for both software, and we saw that we obtained almost the same results. So for that, we can assume that all the generative design results were created properly. Then we developed the structure, the roof structure shape. For that, we designed another script where we can create some variables about the rings, about the shapes, so we can obtain what will be the best shape using their less materials. In this case, combining the different profiles for the secondary, the main beams, and the bracings. We can see the result in the image, and again, we were iterating with generative design to clustering all these results and showing to the people. No, the most important part, it's always been how to deliver the information for non-technical people, so they can understand what is the result. For this case, you can see the results that we can obtain for the structural roof. We get the most optimal solution, and then because we were trying to standardize the facade, we create the relaxation technique for the facade and for the roof. First, we need to reach the average length of the distance that we want to have in the titles, and for that we use this technique. And then when we have this, we create a clustering using machine learning techniques that allows to change these different variables that we have for the title to group in standardized panels. So I will
jump in, but we will give you another 30 seconds.
Okay.
And then...
Okay, yeah. So you can see this is the result. And finally, because the most important part is what are the deliverables, we jump to the BIM auto-renting software. For that, we create the supporting views, so we can share with the stakeholder all the information that it was collected for all these generative designers to get the best result. So finally, most of the problems are due to information exchange and lack of empathy for the project objectives. So being as the enabler of technology and standardization process, and Lean as philosophy focus on the long term, help to resolve these issues. Constructability is based on collaboration, standardization, and repeatability, that's it's converging with BIM and lean approach. And adopting technology allows to mitigate problems such as rationalization design since its conception. We can use the both worlds, the machine and the human, to do best that we can. And using all these mechanisms and technologies require a change of mindset, a culture of respect and innovation to be successfully integrated in the organization. Thank you very much.